Good evening, children. Good evening,
Good
children.
evening, ma'am.
Good evening.
Good evening.
Good evening. Yeah, I just want to go back to this question from NCRT. You've already worked this. Yeah. So, children, you know the trigonometric ratios of complementary angles, some of which go like this. Cos theta is equal to sine 90 minus theta, and sine theta is equal to cos 90 minus theta is equal to cos 90 minus theta. So we know this. Trigonometric ratios of complementary angles. Cos theta is equal to sine 90 minus theta. Sine theta is equal to cos 90 minus theta. Now see here, this question can be done in two ways. I was telling you that, different teachers, see, these are the two ways, and I don't know which of this you learn and you have learned already, or you will be learning in school from your teacher. So let me introduce both of it to you, because in the class the other day, I think I had only one of this presentation. I changed the slide. I just added the other one. The other day when this was discussed in the class, I had only one answer. I didn't have the alternate method. So I just included that, and I want to discuss that now. Okay, so see the question. You need to evaluate sine squared 63 plus sine squared 27 divided by cos squared 17 plus cos squared 73. So clearly, you can convert the numerator and denominator to look like sine squared theta plus cos squared theta. You can convert the numerator and denominator to look like sine squared theta plus cos squared theta. The denominator also sine squared theta plus cos squared theta, or cos squared theta plus sine squared theta. Both are the same. Both will give you 1. Both will give you 1. Cos square theta plus sine square theta, or sine square theta plus cos square theta. Both of which is 1. So 1 by 1. So you know the answer actually. The answer for this is 1 by 1, which is 1. You have to make the expressions look like sine square theta plus cos square theta. And you know that is 1. So 1 by 1, which is 1. So you know the answer already. Now you'll have to show the steps. Oh, see here, children. Now, this is sine square theta. So you write that as it is, sine square 63. You write it as it is because sine square theta, sine square 63. So you write it as it is. Now you want what? You want cos square 63. Cos square theta should be cos square 63. So you'll have to change this one. You have to change this. All right, you'll have to change this one. Okay, now what are the two ways of writing that? Sine square 27 degrees. Okay, now listen very carefully. Oh, we know that sine theta is cos 90 minus theta. In other words, sine square theta is equal to cos square 90 minus theta, squaring on both the sides. Sine theta is equal to cos 90 minus theta, squaring both the sides. Sine square theta is equal to cos square 90 minus theta. Now sine square 27 degrees. Use this rule. Use this rule. What is the rule? Sine square theta. Using it like this, sine square theta is equal to cos square 90 minus theta. So sine square, according to this rule, sine square 27 is equal to cos square. See here. Okay, let me write it below this. 1 minute. So we are using the rule sine square theta is equal to cos square 90 minus theta. So now we have sine square 27 degrees. That is nothing but cos square. See, instead of theta 27. So that can be written as cos square 90 minus 27. That's what you see here. Cos square 90 minus 27. We use this rule. We use this rule, and instead of theta, we substitute 27 degrees. So sine square 27 is equal to cos square 90 minus 27. See, that's what you see here. That's what you see here. So we've already used the rule. In the next step, again, no rule, just subtracting. Just subtracting. 90 minus 27 is 63. We have used the rule here in the first step. So in the next step, you just have to find the difference. 90 minus 27, which is 63. And here you can see sine square 63 degrees plus cos square 63 degrees, which is 1. Same thing in the denominator. In the denominator, I've written cos square 73 degrees as it is because it's cos square theta. I've written that as it is. I'm changing cos square 17. I'm changing cos square 17 to look like sine square something. So how do you change this one? See here, what is the rule used? Cos square theta is equal to sine square 90 minus theta. Cos square theta is equal to sine square 90 minus theta. So cos square 17 degrees is equal to sine square 90 minus 17, because 90 minus theta, theta is 17. So see here, sine square 90 minus 17. Write this as it is. Write this as it is. Now, next step, we've already applied the rule. So in the next step, it's only subtracting 90 minus 17, which is 73. So now this looks like sine square theta plus cos square theta, which is 1. So 1 by 1, which is 1. That's about this one. Now, in the alternate working, in the alternate method, what you see is, see here. See, there are two things. Either apply the rule and then subtract. Or first you show that, the difference. See here. In this one, I've applied the rule. I've applied the rule first. I've applied the rule. I've changed the sine square to cos square. I've applied the rule. I've changed sine square to cos square. Then I have a difference here. In the next step, I'm only subtracting. 90 minus 27 is 63. Cos square 63. Here, what you do is, in the alternate method, so listen carefully. You can change anything, children. So I've written sine square 63 as it is. I want to change this. I want this to look like cos square 63. What I do is this sine square 27. Observe carefully. I have not used the rule. Here I use the rule in the first step itself. Here I have not used the rule. See, what have I done? What have I done? I have not used the rule. I have written sine square 27 as it is. Sine square 27. See here, sine square. Instead of 27, I've written 90 minus 63, which is 27. Which is 27. In the first step, I've not used the rule. I've just written 27 as a difference. 90 minus 63, not 90 minus 27. I'm not using any rule. I'm just writing 27 as 90 minus 63. There we are not using any rule. Write sine square as it is. Write the sine square as it is. Instead of 27, what is 27? 90 minus 63 is 27. 90 minus something. 90 minus what is 27? 90 minus what is 27? 90 minus 63 is 27. So instead of 27 degrees, what you see here is 90 degrees minus 63 degrees. In other words, we've written the same thing. We've written sine square 27 degrees only here. We have not used any rule. Sine square, sine square. Instead of 27, 90 minus 63. So we have not used any rule. In the next step, we use a rule here. In the next step, what we do, this is sine square 90 minus theta. See here, this is sine square 90 minus theta. What is sine square 90 minus theta? Cos square theta. Cos square theta. This is the other way. So in most schools, no, I don't know. In some schools, I've seen this method. So I don't want you to get confused. You can do it both the ways. So I've written the sine square as it is. 27 is written as 90 minus 63, which is the same 27. So no change in the first step. Now this one looks like sine square 90 minus theta. Sine square 90 minus theta is cos square theta. Cos square theta. So in the next step, you can see cos square theta, which is 63. See here, theta is 63. Cos square 63. In the denominator also, I have written cos square 73 as it is. I'm changing this one. So in the first step, I'm not using the complementary rule. I'm not using it. I'm just writing 17 as 90 minus 73. Because 90 minus 73 is 17. So cos square as it is. Instead of 17, cos square as it is, instead of 17, 90 minus 73. So there's nothing but 17 degrees. So no change in the first step. We are not using the complementary rule in the first step. Written this as it is, cos square. Instead of 17, 90 minus 73. Now use the rule in the second step. What is cos square 90 minus theta? What is cos square 90 minus theta? It is sine square theta. What is theta? 73 degrees. Theta 73 degrees on comparing. So sine square 73 degrees. 1 by 1, which is 1. Sine square theta plus cos square theta. So I suggest, you practice this question again. So write down the answer again. You already worked this. Please do it again. Please finish and let me know. Done, children?
One minute, ma'am.
Is it over now, children?
Yes, ma'am.
Got it. Okay. So again, in this one also, the other day when I taught you this, I had only one solution. Then I just changed the presentation. So now you can see both. So here also, children, this one is going to be sine square theta, because there's like a and a, so a square, and this is like b and b into b square. So you're going to make it look like you should like understand that before you start working. So you should look at this, and then this is sine 25 cos 65. So you must make the sine square theta, and this one cos square theta. So sine square theta plus cos square theta is 1. Sine square theta plus cos square theta is 1. All right. So now this is the given expression. So see here, this is sine 25. See, you're working your plan. You're executing your plan. Your plan is this one. This one should be made to look like sine square theta, and this one as cos square theta. So then you should have, if you have sine 25, you should have into sine 25. Then only it will become sine square 25. If you have cos 25, again another cos 25. Then only it will become cos square 25. So what is your intention in the first part? What is your intention in the first part? Since you have sine 25, your intention is to change this to sine 25. Sine 25. So that sine 25 into sine 25 is sine square 25. You can see it here, sine square 25. So if you have sine square 25, you must have cos square 25. You cannot have cos square 65. There's no point. Sin square 25, cos square 65 is not 1. If it is sin square 25, then you should have cos square 25. So obviously, in the second part, you're going to retain cos 25 and you're going to change sin 65 to cos 25. So that cos 25 into cos 25 is cos square 25. And then cos square sin square 25 plus cos square 25 is 1. So you plan that first. So here sin 25 as it is. And in the second part, cos 25 as it is. This one, you're going to change this to sin 25. And here you're going to change this to cos 25. So sin 25 to sin 25, cos 25 to cos 25. Okay, so we're changing cos 65. So what are the two ways of doing it? See here, cos 65. I'm using the rule. I'm using the rule and then subtracting. In the other case, you will first subtract. You will first write it as a difference and then use the rule. Either use the rule. So when you use the rule, you'll get a difference. When you use the rule, you'll get a difference in the bracket. So either you use the rule and then in the bracket you have a difference, you subtract that. Or write the difference first. In the bracket, you write the difference first and then use the rule. So that's all it is. So here I'm using the rule first. What is the rule? Cos 65, cos theta. Cos 65, which is cos theta, is equal to sin 90 minus theta. I'm using the rule first. Cos theta, I'm changing it using the rule. Sin 90 minus theta. See here, sin 90 minus, this is theta 65 because cos theta, cos 65. See here, cos theta, cos 65 is equal to sin 90 minus theta, which is 65. I'm using the rule. So you can see here, sin 90 minus 65. Now I've used the rule. So next step, I should only find the difference. What is 90 minus 65? 25. Sin 25. Don't again use the rule. You've used the rule already. Now just find the difference. 90 minus 65 is 25. Sin 25. Here also in this part, sin 65, I'm using the rule. What is sin 65? Sin theta, cos 90 minus theta, 65. Now I've used the rule. Now in the next step, I'll only subtract. Cos 90 minus 65 is 25. Cos 25. So see, I applied the rule. And then next step, I'm only subtracting. 90 minus 65 is 25. Cos 25. And then this product is sin square 25. This product is cos square 25, which is 1. In the alternate method, what we do is, again, same idea. This is sin 25. This is cos 25. I'm not changing that. I want this to become sin 25. I want this to become cos 25. See, children, you can also do this like cos square 65 plus sin square 65, depending on what you change. See, there are two angles here, 25 degrees and 65 degrees. Either you can make the expression look like sin square 25 plus cos square 25. Or you can make it look like sin square 65 plus cos square 65. So you decide which angle you want to retain. There are two angles, 25 and 65. So if you want to retain 65, then you change the 25s. If you want to retain 25s, you change the 65s. So that is left to you. I have worked this by retaining 25. I'm retaining 25. I'm changing the 65s to 25s. Okay, so see, I want this 25 as it is, this 25 as it is. So sin 25, cos 25 as it is. Now here what we do is, excuse me, we don't use a rule first. First we write the difference. We're not using any rule. That means you cannot change cos to sin. You're not using the rule. Cos will be cos only. 65 will be 90 minus 25. So you're not using, see, 65 is 90 minus 25. All of us know that. So in the alternate method, we write cos as it is here, cos. 65 is written as a difference, 90 minus 25. There is no rule there. Sin 25 as it is, cos as it is, 65 actually as it is, but instead 90 minus 25, which is 65. No rule there. Then cos 25 as it is. And then, because I told you, we are retaining the 25s, we're changing the 65s. So this one, see the sign I've written as the sign. I've written sign as this. 65 as a difference, 90 minus 25. So in the first step, no rule. No rule is used. In the second step, I hope it's clear. In the second step, now this is cos 90 minus theta. What is cos 90 minus theta? Sin theta. So sin theta, sin 25. See here, sin 25. And here sin 90 minus theta. Sin 90 minus theta is cos theta. Cos 25. See here, cos 25. So the two ways are either use the rule, the complementary rule, and then find the difference, or write it as a difference. You're not using the rule. You'll write sin as sin, cos as cos. You're not using the rule. So first write the difference and then use the rule. Both will give you the same result. Yes, children, please practice this. Please put your mind into the answer. Do not blindly copy. You can go through the, methods, both the methods, understand, and then start writing. Done, children?
Yes, ma'am.
All right. Class use the emoji. Raise your hand. Nandini, Pranav, after a long time, Pranav, Sashmin, Tarun, Murali, Hitesh, Harini, Sneha, Raja Rajeshwari, Priyanka, Nanya, Ramnathan, Kanishka, Murali Krishna. All right. Yeah. Good children. Yeah, we finished all this. And I just want to talk to you about the tests which I've scheduled. Okay. Now tell me how many of you have not yet attempted any test? Lower your hands and raise your hand, children. Lower your hands, all of you. How many of you have not yet attempted any test? Raise your hand. Ananya, Kashmeen, Pranav. Priyanka, you've done, is it?
Yes, ma'am.
Now, some of you might know because you've been in this classroom last year. For the others, I hope there was nothing difficult because we have gone through online classes for the last 2 years since COVID hit us. So I did not explain much because I shared the URL. You just had to tap on it, use your credentials, and it takes you to your account where you can see the test scheduled. Anyone is not able to access the test at all? Is there anyone who needs help regarding where to see the tests? Yes, please tell me now. So if you're use a laptop, that will be, that gives you a good experience, whether it is a classroom or, taking up a test. Doing on a mobile is tedious. So a bigger screen will give you a better experience. So you just have to, type the URL on the browser. So open your Google or your Microsoft Edge browser, whichever browser you use on the laptop. Open the browser, and there you just have to type atharv.testpress.in. Atharv.testpress.in. I'd share the URL. So you just have to type that on the browser, that URL, atharv.testpress.in. So that will take you to a place where there's a dialog box asking you to enter your credentials, username and password. So that I had shared on WhatsApp. So you got your username and password. You just have to enter that, and it takes you to a different screen where you can see all the tests assigned to you. Yeah. That's all it is. It's as simple as that. And then you start the exam and you can, just a minute. Yeah, supposing since you've all not attempted it, just take the first test. I know some of you have not still completed the first one. 11 of you have completed the first test. So let's see the. Can you, which screen are you able to see now, children?
Yes, ma'am.
You're able to show the screen on which your results are displayed?
Yes, ma'am.
Okay, so here you can see Pranav is, not out of the exam. He's not ended the exam, so I can still see him there. August 9th. Today is August 9th. Okay, he's just logged in. Pranav is just logged in. You can see the time here, 8:21 against Pranav. Ananya, 5 correct, 3 incorrect. Can you see the screen from which I'm reading, children? Have I shared the correct screen? Can you see this here? Access codes, offline codes. Can you read that? Are you able to see the same
Yes.
screen I'm seeing? Okay. All right.
Yes,
Yeah. So I can see Sneha. 3 correct, 5 incorrect. Harini, 6 correct, 2 incorrect. Kanishka, Ramnathan, you can see. So I can see your scores as well. I can see when you logged in. See here. So Ananya's taken the test today. She's taken test 1 today, Ananya.
I
So she's
forgot that you assigned the test, ma'am. Today, after when I was coming back from school, I saw your message for today's class and I did it. I only reached home at 6:30 today, ma'am, so I did it at. I mean, I'm sorry, ma'am. I completely forgot about the test.
okay, fine. Please make sure you take up the tests.
Yes, ma'am. Yes, ma'am.
Yeah, at least complete them by this weekend.
I will, ma'am. Definitely.
Yeah. So yeah, see here, she started at 7:03 and she's finished at 7:32. Can you all read what I'm reading?
Yes, ma'am.
Yeah, then Sneha, like that, I can see against every student. I can see the time the child is when and what time, when August 8th, whatever date, and the time the child is logged in and when the child has ended the exam. And children, see, I always give more than sufficient time. The exam, maybe I've scheduled the exam for 1 hour. So don't assume that you can work those questions for 1 hour. I always give more, almost double the time I give. If not double, at least 1.5 times the time you need, I give. Because I don't want any child to run short of time and, omit questions. Though you know the answers, you just run short of time and the exam, the exam ends on its own at the end of that time. So you supposing I've scheduled the exam for 1 hour. I've scheduled the exam for 1 hour. You started, say 8 o'clock today. It will be automatically submitted at 9. It will be automatically submitted at 9. If I've scheduled it for 1 hour, you can take it anytime. You can take it up today because I have not set any end date for the exam. So supposing I schedule a bunch of exams today, that will be available to you. I don't give normally the end date is there, but I don't do it because different children have tests, homework, whatever at school at different points of time, and you all of you might not have the time to complete the exams at the same time, which is why I don't set any end time. So the exams are always available to you. You can take it up at any time, but when you start the exam, the duration will start from there. So if you start the exam today at 8 o'clock, from there 1 hour, 9. So if you don't finish by 9, the exam automatically ends. The paper is automatically submitted. No time beyond that. So that's what it is. So now don't blame me. Don't say that you always gave us more time, so my speed is reduced. Kindly don't blame me. I don't want to give you just the right amount of time because I want you all to experience all the questions, understand your strengths and weakness. So that is why I give you more time. I want you to, attempt all the questions. So if you should actually finish it in half an hour, I'd have given you 1 hour's time. So do not always you maintain your speed. You work like as if the next minute the paper is going to be submitted, as if next minute the exam is going to end. So you start working like that. You don't relax. okay, just 4 questions, 1 hour, I have a lot of time. So start the exam, then go for some snack, come back. Don't do that. Don't do that. You work as if, anytime the exam is going to end, you don't know. Anytime it will end. So you work in your speed, you increase your speed. See to that you finish in that less, meaning if it's for 1 hour, try to finish it in less time. 45 minutes, half an hour. That is one thing. I always give you more than sufficient time. So don't tell me that I became very slow. I used to do my exams very fast, but since you gave us a lot of time to do, to do the tests, my speed is reduced. Kindly don't blame me. That is one thing. Otherwise, nothing else. That's all I have to tell you about the duration. So like this, I can see against every student, I can see when the child is logged in. So there will be a child like, you log in at, you start the exam at, 8 o'clock and 8:01 the paper is submitted. That means randomly you've selected the answers. 8 o'clock and then 8:01 paper is submitted or 8:05 exam ends. So that means you've simply done inky, pinky, ponky, some ABCD randomly and you have given the exam. So that also is very clear.
Ma'am, I have done all of the trigonometry tests except for the test one, ma'am. I'll complete it after this class, ma'am.
Oh, okay. Priyanka has completed all except test 1, is it?
Yes, ma'am. In trigonometry, I've completed the other tests except for test one.
Okay, fine. And again, if I want to see, where Kanishka has gone wrong, because, I know Kanishka is, like all the others in the class, she's also a super smart child, but why has she made 2 mistakes? So I want to see where she's gone wrong. So here I go and I view Kanishka's answers, but Kanishka is not in the class today. So I go to Kanishka's, see here, I can go there and I can view her answers, where she's gone wrong, which 2 answers of hers are incorrect. So you can see her you can see the questions in test 1. Test 1, she's given. Okay, so this green means correct answer. I'll show you where she's incorrect. So see here. Here, if 2 sine 2 theta is equal to √3, then the value of theta is. So here she's gone wrong. I don't think I can annotate on this screen. No, I cannot annotate on the screen. 1 minute. No, I can't. No, children. Yeah, I cannot write on the screen, children, but the 5th one you can see. If 2 sine 2 theta is equal to √3, then the value of theta is. So 2 comes to the other side for division. So sine 2 theta is equal to √3 by 2. So when is it √3 by 2 in the sine table? Sine 60. Sine 60 is √3 by 2. So we have sine 2 theta is equal to √3 by 2. √3 by 2 is sine 60. So sine 2 theta is equal to sine 60. On comparing both the sides, sine gets cancelled, but actually you're not supposed to cancel sine. I'm just telling you. So it's like sine, cover the sine on both the sides. So you have 2 theta is equal to 60 degrees. So theta is equal to 60 by 2, 30 degrees. So the correct answer is 30, but she's given 60. She's given 60, but the correct answer is B, 30 degrees. So like this, I can go and see, where the child has gone wrong. If there are 2 incorrect answers, which 2 are incorrect? So I can go down and see. So like that for every child. So these are, you can see right on top here, show results for students who have, you can see I have another option, show results for students who have not attempted instead. Okay, so if I do that, I'll get the list of students who have not attempted. So you can see here, Deepika, Hitesh, Meera, Sashmin, Netra, and for test 1, Priyanka. So these students have not still taken the test. So if I can just, switch between these 2. So when I click on this, so I can see the list of students who have completed the test. So these students have completed the test and I can see the various statistics about each student. How much time you have taken to solve, every answer. So there are many other options which I can, see and understand the performance of a student apart from the score the child has got. So when I click on this, I can see the list of students who have not attempted the test. So these students have not taken the test. So like this, I can do for every test. So this is how the portal looks for me. For your standard. Yeah. Yeah. So these are the exams which I've scheduled for you. Earlier you saw for other standards also. So these are the tests. So you have test 1 trigonometry. See from below, you have test 1. Able to see the screen, children, all of you?
Yes, ma'am.
Yeah. So you can see below test 1 trigonometry, test 2, 3, 4, 5, 6, 7, 8, 9, 10 trigonometry. Then test 1 again. For every chapter, the number will start from 1. So you don't get confused with that. Test 1, that was of trigonometry. This is test 1 of linear equations. This is test 1 of linear equations. So you don't mind the number. It's a different paper. If so, when you see test 1 again, don't think I've rescheduled the same exam. This is a different one of a different chapter. So you can see test 1 linear equations, test 2 linear equations, 3, 4, 5. So you have so now you have 10 on trigonometry and 5 exams on linear equations. Yeah, I told you the duration is always more than sufficient. So you work, with your usual speed, or you work still faster. And as I told you, just think that your exam might end anytime. So you maintain the speed and complete it fast. Fine. I just wanted to tell you that, I can see, you don't have to share your results. I can see your results. All right. Yeah, children. So I just wanted to, do those 2 questions again. Now let's continue from where we stopped. Yeah, I think we finished this one. The third one. Yeah, please help me know. We finished this, right? Yeah, please help me. Have you finished this one? One of you answer. What's the problem? Please help me. From where should we continue?
Ma'am, from 5th one only, ma'am.
5th one, huh? Or this one?
Ma'am, you explained this, ma'am, but you didn't explain the alternate method for this third subdivision, ma'am.
Very good. So we have to continue from the 4th one. Is it after this? Okay, Nandini. Fine. Let me do the alternate method. Yes. So here, thank you, Nandini. Fine. So here, children, we need to prove this trigonometric identity. So you can see here tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to secant theta cosecant theta plus 1. So according to the rules, we have a few rules. So one of it says if we have other ratios, convert them to sine and cos. So here in the left hand side, we have the ratios tan and cot. So the rule says, one of the rules says if you have other ratios, change them to sine and cos. So that's how we, work the first method here. So we change tan theta to sine theta by cos theta and cot theta to cos theta by sine theta. And proceed. That's about the first one. There's another rule which says that if in an expression we have only tan and cot, you can either change tan to cot or cot to tan. I have been discussing various rules using which we, get started with the proof. You should have made a note of all that. See, everything I say, I cannot, make notes of all that and share it with you. So when I say something, if you feel that's an idea, you should have made a note of it. Whenever there's something common, take out that. And then identities, using algebraic identities wherever needed. So you should make a note of all that. You should have made a note of all that. So one of the rules says that if we have other ratios, change them to sine and cos. That's how we have worked the first method, changing it to sine and cos. But there's another rule which says if in the expression you have only tan and cot, then you can either change tan to cot or cot to tan because they're reciprocal ratios. So that's the idea or the rule we've used here. I have changed cot to tan. See, again, you can change tan to cot, meaning you can have cot everywhere. You can have cot everywhere, cot theta everywhere. That method I don't have, but you can also do that. You can either change all tan thetas to cot theta or all cot thetas to tan theta. So I have changed the cot to tan. All right. Okay. So see here, the LHS is tan theta by 1 minus cot theta. 1 minus cot theta. You can see the LHS here by 1 minus cot theta. So I've written cot theta as 1 by tan theta. I've written cot theta as 1 by tan. See here. 1 minute. Well, let me write the LHS here. Let me write the LHS here. LHS is equal to tan theta divided by 1 minus cot theta plus cot theta by 1 minus tan theta. This is the LHS. So in the next step, you can see tan theta in the numerator as it is divided by cot theta is 1 by tan theta. So 1 minus 1 by tan theta plus in the numerator, we have cot theta, which is 1 by tan theta divided by 1 minus tan theta. So there's no cot now. It's all tan. Now, that's all. Once you do this change, then you just have to take the LCM and all that. So you can see this is the denominator. You can see the LCM here. In the numerator, we write this tan theta as it is. In the denominator, common denominator. Tan theta is a common denominator. So numerator, you'll get tan theta minus 1. Tan theta is a common denominator. So you can see tan theta minus 1 in the numerator. And here 1 by tan theta, there's nothing, no LCM and all that. So we write that as it is 1 by tan theta by 1 minus tan theta as it is. Now, next step, children, to make it more clear, I always write it using the division symbol. See, this is the numerator. So you can see the numerator here. Divided by this one, divided by this full thing is the denominator. So you can see the denominator here. Tan theta minus 1 by tan theta. See, I've just written it like numerator by denominator here. Here also numerator by denominator. So you can see this one is the numerator. This is the denominator. This is the numerator. This is the denominator. You can see that. Numerator tan theta divided by the denominator plus 1 by tan theta is the numerator divided by the denominator 1 minus tan theta. Please ask me, children, if I'm not clear. Is this step understood? All right. Okay. In the next step, so tan theta division becomes multiplication and reciprocal. Plus 1 by tan theta division becomes multiplication and reciprocal. 1 minus tan theta, reciprocal of that is 1 by 1 minus tan theta. Because it's by 1 here. So reciprocal of that. If it's 5, reciprocal is 1 by 5, like that. So that's about this step. So see, we just changed all the cot theta to tan theta. That's all we did. Nothing else. That's the rule. If we have only tan and cot, here we have changed all the cot to tan. That's the rule. We applied the rule. That's all. See, that took us to the next step like this. And from there we came here. No, nothing else we used. And from there, the step. Now multiply the numerators. Whenever it's multiplication, that's how it works. If you have 3 into 2 by 5, what will you do? 3 into 2, 6 by 5. Similarly, tan theta into tan theta, tan square theta, by tan theta minus 1, by tan theta minus 1. Denominator into denominator, nothing in the denominator. Like, see, 3 into 2 by 5, meaning by 1 it is. So 3 into 2, 6 by 5. So here tan theta into tan theta, tan square theta, by there's nothing here. So 1. So it will be tan theta minus 1. Then plus again 1 into 1 is 1. And then multiply this. You can see it here. That's what is here. See, children, very important is, when I'm explaining, you should not go ahead of me. Don't see. Now you can see many things. If I'm writing on the whiteboard, you will be focusing on what I'm writing. But here, since the complete answer is on the screen, don't go ahead of me. So you should train your mind like that. When any online class, if the answer completely is in front of your eyes, you should tell yourself that, no, I'm not going ahead of the teacher. See, if the floor is slippery, what will you do? If the floor is slippery, automatically you walk slowly. You make sure that, you're very careful when you put your foot ahead. But if it's a rough surface, you can even run. So you act according to the situation. So like that, here you see the complete answer on your screen. So you don't wander your eyes and your mind throughout the answer. We'll go together, we'll sail together. That's very important, always. Don't read the answer ahead of me. Focus on what I am explaining. Don't go ahead, don't see anything ahead of it. That will only confuse you. So we are here now. Now after this, what happens? Look at the denominator. Every step you'll have to be watchful. Look at the denominator. Here it's like a minus b. Here it's like b minus a. Tan theta minus 1. Because after this you'll have to take the common denominator. When you have something like this, after this you have to take the common denominator because there's a plus sign here. So what will be the common denominator? So for that, when you look at the denominators, you see tan theta minus 1 here and 1 minus tan theta here. So you're like, both are not the same, but you can make them look alike. They're not the same. Tan theta minus 1 and 1 minus tan theta, they're not the same, they're different, but you can make them look the same. You can make 1 minus tan theta minus 1. So it's easy to take the LCM. Because next step is LCM, common denominator. So you see tan theta minus 1 and the same terms, but 1 minus tan theta. So what you do is you write 1 in the next step. What you do is you write 1 minus tan theta as tan theta minus 1. Why are we doing this? Because we have to take the common denominator because there's a plus sign in the middle. See, when there's a multiplication, you multiply the numerators, multiply the denominators. Now there's a plus sign in the middle. So you have to take the common denominator. So when you look at the denominators, this is what you see, tan theta minus 1, 1 minus tan theta. So what you do in the next step is you write 1 minus tan theta as tan theta minus 1. And take a minus outside. I've told you this earlier. If you write a minus b as b minus a, take a minus outside. Take a minus outside. So what happens? 1 minus tan theta is written as minus of tan theta minus 1. There's actually plus here. See here, this is plus, this is plus, this is plus. Now this 1 minus tan theta is written as minus of tan theta minus 1. So there's a minus here. Minus into plus is minus. That's why you see a minus sign here. So you can remember like this. When you write 1 minus tan theta as tan theta minus 1, change the connecting sign. The connecting sign will become its opposite. If it's plus, make it minus. If it's minus, make it plus. You can remember like that. We have written 1 minus tan theta as tan theta minus 1. That can happen only when you take a minus outside. So change the connecting sign. This plus will become minus because when you multiply that minus sign with this plus, it becomes minus. When you write a minus b as b minus a, change the connecting sign. Plus will become minus, minus will become plus. Now take the common denominator. What's the common denominator? Tan theta minus 1, tan theta minus 1, tan theta. So tan theta and 1 tan theta minus 1. See, think about it like this. 1 by a, I'm just saying 1 by a, or say, okay, say tan square theta by a, tan square theta by a minus 1 by ba. What will be the common denominator? Because I'm just taking this as a, children. Okay, let me show it here itself. This one, tan theta minus 1, I'm calling it a. This one, I'm calling it a. And say this is b. This is b. Okay. So a and ba, what's the common denominator for a and ba? ba. For a and ba or ab, the common denominator is ab. You have 1 by a and 1 by ab. So ab is the common denominator. So tan theta into tan theta minus 1 is a common denominator. So now multiply. So you need to multiply here. This is tan theta minus 1. So you should multiply by tan theta. Multiply this by tan theta. Just the way you take the LCM. Multiply this one by tan theta. So you get tan cubed theta. Tan square theta into tan theta is tan cubed theta. Minus 1 as it is. LCM, nothing else. Common denominator. How do you work with numbers? Same thing here. Now the numerator is in the form a cubed minus b cubed because 1 is nothing but 1 cubed. 1 is nothing but 1 cubed. The numerator is in the form a cubed minus b cubed. So a cubed minus b cubed is a minus b tan theta minus 1. See here. Tan cubed theta minus 1 cubed. So a is tan theta. A is tan theta. And b is 1. A minus b tan theta minus 1 into a square tan square theta plus ab tan theta into 1 plus b square 1 square which is 1. So I'll write the identity for you just in case you've forgotten. 9th standard a cubed minus b cubed is equal to a minus b of a square plus ab plus b square, wherein a is tan theta and b is 1. B is 1. So you can make a note of this in the, in the whatever in the side here, in case you have a doubt. Here you can write that. So the numerator is like a cube minus b cube by the identity a minus b, a square plus ab plus b square by the denominator as it is. By the denominator as it is. Next step, you can see tan theta minus 1 gets cancelled. Tan theta minus 1 and tan theta minus 1 gets cancelled. Now, can you see this tan square theta plus 1 is secant square theta. Identity. Tan square theta plus 1 is secant square theta. So secant square theta plus tan theta divided by tan theta. Next, secant square theta by tan theta. Tan theta by tan theta. You understand that? Next step. Okay. Secant square theta by tan theta plus tan theta by tan theta. So tan theta by tan theta is 1. Secant square theta by tan theta. See, all these steps is for you to understand, children. I'm not writing anything directly. So see here, now secant square theta by tan theta. So I've written it like the secant square theta by is divided by tan theta, which is signed by cos. Tan theta, which is signed by cos. Plus 1. Don't forget this plus 1. Now, what is the RHS here? What are the RHS? Secant theta, cosecant theta plus 1. secant theta, cosecant theta plus 1 is the RHS. Okay. So now, see, if you want, you can change this, secant square theta to 1 by cos square theta also. You will get it. Even if you change it here, I have not changed because maybe I thought there is secant theta here. In the RHS, there is secant theta, so why change? You can even change it to 1 by cos square theta. You will change, and you will come back to the RHS. So I have not disturbed that sine square, secant square theta. Well, you can also write it as 1 by cos square theta. That's what I'm saying. You can also write it as 1 by cos square theta, reciprocal ratios. I have written secant square theta as it is into reciprocal, cos by sine. Cos by sine. Okay, plus 1 because division becomes multiplication and reciprocal, cos by sine plus 1. So secant square theta into, what is the meaning of cos by sine into cos theta into 1 by sine theta? Cos by sine. See, you're just doing all this so that you're separating things. That's all. Cos by sine is nothing but cos into 1 by sine, like a by b can be written as a into 1 by b. A by b can be written as a into 1 by b. Can be written as a. So similarly, I've written cos theta into 1 by sine theta plus 1. So now cos theta is nothing but 1 by secant theta. So secant square theta into 1 by secant theta into 1 by sine theta is cosecant theta. Now secant and this one gets cancelled, so we'll have one secant theta here. So secant theta into cosecant theta into 1 is secant theta cosecant theta plus 1, which is the RHS. Which is the RHS. Yeah, please write the alternate method, children. So you have to remember only two things here. One is changing cot to tan, and the other is the identity, a cube minus b cube. Identity. And one more thing is a minus b, b minus a. How do you write a minus b as b minus a? Minus of b minus a. That's all. These three things. Yeah, start writing. See, children, this part, you can also work like this. So, see this part. Work till here and let me know, children. I'll tell you how you can also work this one. Please work till here and tell me. Don't write this. Done, children? No, I think I'll have to set some time, like, 2-3 minutes to write. 2 minutes to go through, 3 minutes to write. So 5 minutes and go to the next slide. I'm not going to ask you because nobody responds. Yeah, another 30.
Done.
Yeah, done. So till here it's over. Till here it's over. So you can
Yes,
also yeah, secant square theta by tan theta plus 1. You can also continue like this. Secant square theta by tan theta plus 1 we have, plus 1. See here, this step. See the last step here, secant square theta by tan theta plus 1. You can also continue like this. So to understand better, I wrote secant square theta divided by tan square theta like this, tan theta plus 1. So you can change secant square also, because again, there is a rule which says if you have other ratios, change it to sine and cos. So going by that, you can change this. 1 by secant square theta, sorry, secant square theta is 1 by cos square theta divided by tan theta sine theta by cos theta, tan theta sine theta by cos theta plus 1. Okay, plus 1. Now this is equal to 1 by cos square theta into cos theta by sine theta plus 1. So what happens? Cos theta, cos square theta. You can simplify, so you will get 1 by cos theta. On cancelling, you will get 1 by cos theta into 1 by sine theta. Into 1 by sine theta. On cancelling cos theta and cos square theta, you will get 1 by cos theta into 1 by sine theta plus 1. What is 1 by cos theta? Secant theta. And what is 1 by sine theta? Cosecant theta. Plus 1, which is the RHS. Maybe if I work it this way, see, that was also right. You saw that we got the RHS. Maybe when I work it like this, I can justify better that, because I tell you, always that when you have other ratios, change it to sine and cos. So when I work it like this, I can justify that better. So please take down this. Don't do this. It's correct, children. See, that's what it is. Once you, get a good hold of solving or proving identities, you will understand. Nothing is incorrect. Like, don't do this one. After this, please continue like this. Yeah, 30 seconds. I'm going to the next slide. Yeah. Done. It's so difficult to be rude, yeah, done, children. All right.
Yes, ma'am.
All right. This is the next one. Prove that 1 plus secant theta by secant theta is equal to sine square theta by 1 minus cos square theta. So it's a very simple one. The rule which says change other, this is the LHS, watch fast. This is the LHS rule, change other ratios to sine cos. So secant is 1 by cos, secant is 1 by cos. Then I've written it so that we understand better. This is the numerator. This is the numerator. This is the denominator. This is the numerator. This is the denominator. You can see here, this is the numerator I've written, divided by the denominator here. Please watch that. So in the numerator, when you take the LCM or the LCM, so you get 1 cos theta plus 1 by cos theta in the numerator. Cos theta plus 1 by cos theta. You can see the numerator here. Cos theta plus 1 by cos theta divided by the denominator 1 by cos theta. You can see it here, 1 by cos theta. Next step, division becomes multiplication and reciprocal. So cos theta plus 1 by cos theta as it is, division, multiplication, reciprocal of 1 by cos theta is cos theta. Cos theta and cos theta gets cancelled. Cos theta and cos theta gets cancelled. Then we have cos theta plus 1. We have cos theta plus 1. Okay, which can also be written as 1 plus cos theta. Why did we write it as 1 plus cos theta? Because when you look at the RHS, when you look at the RHS, you have not 1 plus cos theta is not the RHS. You need to still work ahead. And what do you have in the RHS? Sine square theta by 1 minus cos theta. So we wish to have this as 1 plus cos theta. It's not cos theta plus 1 here. It's 1 minus cos theta. So you want to have it as 1 plus cos theta here. So that to continue. See here, this after cancelling this is cos theta plus 1, which can easily be written as 1 plus cos theta. They're the same. A plus B, B plus A, they're the same. You don't have to take a minus outside. Now, why should we write cos theta plus 1 as 1 plus cos theta as a question? That's because you see in the RHS, it's 1 minus cos theta. So you want 1 plus cos theta here so that you can multiply and divide by 1 minus cos theta, which is here, 1 minus cos theta. So when you have cos theta plus 1, please write it as 1 plus cos theta and proceed. How? We have not still got the RHS. So multiply and divide by 1 minus cos theta, the opposite sign. 1 plus cos theta. So multiply and divide by 1 minus cos theta. So 1 plus cos theta into 1 minus cos theta. A plus B into A minus B. A square minus B square. 1 square minus cos square theta. Divided by 1 minus cos theta. Now the numerator 1 minus cos square theta sin square theta by the identity, and 1 minus cos theta as it is, denominator 1 minus cos theta, which is the RHS. Yes, start writing. Hence proved. 1 minute. I'm looking into my mobile. 1 minute. Yeah, it's time. Yes. Next one. So no children, see, so it's so difficult to do that, Please acknowledge if you're finished. It's so difficult to do that.
10 now.
Yeah. Okay. Yeah, there's the next one, children. Prove the following identity. So you can see that. Am I doing it right, children? We have not finished this right earlier? Nandini?
Yes, ma'am.
We have to do this right?
Yes, ma'am.
Okay. So what do we see here, children? There's again a rule here. We see that in this identity, the LHS is made up of cos theta, sin theta, and 1, or cos A, sin A, and 1. In which case, you have to start by dividing both the numerator and denominator by either sin theta or cos theta. This is a rule. When the LHS or the RHS, when in the identity, one side of it, that is the LHS or the RHS. So here the LHS, it's made up of cos A, sin A, and 1. Cos A, you in both the numerator and denominator, you only see cos A, sin A, and 1. In this case, you will have to start by dividing both the numerator and denominator by either sine A or cos A. Now you will have to decide by what to divide. By what to divide. So let's do that. Let's decide now. Cos A, I'm just writing the numerator cos A minus sine A plus 1. Now supposing we divide the numerator by sine A. By sine A. Okay, the denominator also. What's the denominator? Cos A plus sine A minus 1 divided by sine A. You're dividing both the numerator and denominator by sine A. Now again, this might look like, how can you do this? How can you just change the expression? How can you just divide the numerator and denominator by sine A? Will you not change the value of the expression given? That's what we always do. See here. Now when we simplify 25 by 30, what are we doing? We know it's 5 by 6. What are we doing there? 25 by 5, 30 by 5. That's what we're doing. What are we doing? 25 by 5, 30 by 5. You're dividing both the numerator and denominator by 5. And what is it? 25 by 5 is 5 and 30 by 5 is 6. And that's how you get 5 by 6. It's absolutely fine. You are not changing the value of the expression when you divide the numerator and denominator by the same expression. So when you divide the numerator and denominator by sine A, what do you get? Cos A by sine A, cos A by sine A, cot A, sine A by sine A 1, 1 by sine A cosecant A. Yes, it works. We are getting cot A and cosecant A, which is in the RHS. When you divide by sine A, you are getting cosecant A and cot A, which is in the RHS. So you have to divide the numerator and denominator by sine A. So because the RHS is made up of cosecant and cot, cosecant and cot. So this is the LHS, children. We have to, because the numerator and the denominator is only made of one sine A and cos A, or we have to start by dividing the numerator and denominator by sine A or cos A. But here it is by sine A. What do you get? This is the step. You're dividing the numerator and denominator by sine A. Then divide the terms individually. Cos A by sine A, you can see a cos A by sine A minus sine A by sine A plus 1 by sine A. Cos A by sine A, you can see all this. And then write there, write what it is. Cos A by sine A is cot A. Sine by sine is 1. 1 by sine is cosecant. Cos by sine is cot. So you can understand the step. So the start is important. That's all, nothing else. How to start? You should start by dividing by sine A. Now, when you divide by sine A, see, you're getting cot A and cosecant A. That's what is in the RHS. That's what is in the RHS, cosecant and cot. Okay, so after this, I've told you. After this, what you should do, don't disturb the denominator. We have done one similar one earlier. Example, don't disturb the denominator. Once you have converted all the ratios to what is in the RHS, cosecant and cot, don't change the denominator. Write it as it is. The denominator will come as it is. Till the end, it will come as it is. See, the same thing will come. Finally, it will get cancelled. Don't do anything with the denominator. I've just rewritten it, I've just written 1 minus cosecant. You can write it as it is, children. See, maybe when you know what is going to happen in the end, you do it here itself. So when you don't see the end, you don't do it. How do you know? Now you will ask me, how will I know that there are so many, identities of them? How do I know that here I have to write it as 1 minus, how do I know I should write it like 1 minus cosecant A plus cot A? Correct. How do you know? We don't know. So you will write it as it is only. You write it as it is. You please write it as it is. You don't have to write it like this. You can write it as it is. Okay, so denominator, no change. Write it as it is. In the numerator, in place of 1. In the numerator, in place of 1. So see here, write this as cot A plus cosecant A, which is nothing but, see here, cot A plus cosecant A. Cot A plus cosecant A. Can you see here? Minus 1. Cot A cosecant A minus 1. Minus 1 here, minus 1. So in the numerator, in place of 1, write it as cosecant square A minus cot square A. Write cosecant square A minus cot square A. All right. Why? Yeah. Why cosecant square A minus cot square A? Because You can see the RHS is cosecant and cot. See, one can be written as sine square A plus cos square A. One can also be written as secant square A minus tan square A. And these are three different ways of writing one. One can also be written as cosecant square A minus cot square A. And we choose to write one as cosecant square A minus cot square A because we have the RHS like this. So a relevant one you should use. So in the numerator, denominator not disturbed. In the numerator, in place of -1. So the other terms as it is, cot A cosecant A as it is. Cot A cosecant A, -1. Denominator as it is. Now in the next step, write this cot A cosecant A as it is, minus, instead of 1, you can see a cosecant square A minus cot square A. Cosecant square A minus cot square A. Instead of 1, cosecant square A minus cot square. Now in the next step, A square minus B square is A plus B into A minus B. That's the next step. Then you have something common. You have something common in the two terms, two expressions here. So I've just called this one X. You can understand this. So X is common. X is common. So in the bracket, you will get 1 minus Y. That's what you get normally. X minus XY. If you take out X common, you'll get 1 minus Y in the bracket. You'll get, that's what it is here. So I've taken out X common and 1 minus Y you get in the bracket. 1 minus Y. The denominator as it is. So that gives you cot A plus cosecant A into 1 minus cosecant A plus cot A on opening the bracket. So now this gets cancelled. Cot A plus cosecant A, which is the RHS. Which is the RHS. Or cosecant A plus cot A, which is the RHS. Just start working, children. We start working. Here also you can write cosecant A first. Please write, children. Incorporate the changes I've done. Done, children? Finished writing? Okay. Done, children?
Yes, ma'am.
Okay. All right, we'll wind up the session with this one. We'll finish this and wind up the session for today. So here, a root of, you need to prove that root of 1 plus sine alpha by 1 minus sine alpha is equal to secant alpha plus tan alpha. So what you have to do, square root of LHS 1 plus sine alpha, square root of, take the LHS, it's 1 plus sine alpha by 1 minus sine alpha. So like, you know, last year we used to rationalize the denominator, use the same idea. The denominator is 1 minus sine alpha. So multiply and divide by 1 plus sine alpha under the square root. 1 plus sine alpha under the square root. Extend the square root, and under the square root, since the denominator is 1 minus sine alpha, you multiply and divide by 1 plus sine alpha. 1 plus sine alpha. That is the first step under the square root. Next step, multiply the numerators because it's multiplication. Multiply the numerators. 1 plus sine alpha into 1 plus sine alpha. 1 plus sine alpha the whole square divided by 1 minus sine alpha into 1 plus sine alpha. A minus b into a plus b. A square minus b square. A square minus b square. A minus b into a plus b. Multiply the denominators. A square minus b square. Now the smart thing is, if you want to get rid of the square root, you can see the RHS. It's free of the square root symbol. The RHS is free of the square root symbol. There is no square root symbol in the RHS, which clearly means you have to get rid of the square root symbol. You have to somehow get rid of the square root symbol. How can we get rid of the square root symbol? You need to have perfect squares under the square root. You need to have perfect squares under the square root. See, you will be very happy to solve this 9 by 16 because you know it is 3 by 4. 9 is a perfect square, 16 is a perfect square. So you can get rid of the square root. It's 3 by 4, free from the square root. So similarly here, how do we get rid of the square root symbol? You need to have the numerator and denominator as perfect squares. And when you look at the numerator, it is already a perfect square. 1 plus sine alpha, the whole square, it's already a perfect square. So you're happy. The numerator is already a perfect square. 1 plus sine alpha, the whole square. It's a perfect square. Don't disturb it. It's a perfect square. The denominator is not a perfect square. It's 1 minus sine square alpha. It's not a perfect square. But we know that 1 minus sine square alpha is cos square alpha, which is a perfect square. 1 minus sine square theta is equal to cos square theta. 1 minus sine square alpha is equal to cos square alpha, which is a perfect square. Cos square alpha is a perfect square. So now under the square root in the numerator, we have 1 plus sine alpha into 1 plus sine alpha. So one of it will come out of the square root divided by, in the denominator, we have cos alpha into cos alpha, cos square alpha. So it comes out of the square root as cos alpha. Now here we are free of the square root symbol. From 2, 1 plus sine alpha, 1 comes out. Cos alpha, there are 2. 1 comes out of the square root. Now it's 1 by cos alpha plus sine alpha. This step happens in most places. 1 by cos alpha plus sin alpha by cos alpha, writing the denominator like this for each term in the numerator. So now 1 by cos alpha is secant alpha, sin alpha by cos alpha is tan alpha, which is the RHS. Write down, children. Done, children?
Not yet, ma'am.
Okay, okay. Yes, children, are you done?
Yes, ma'am.
Yeah. Now, please, now Thursday is a holiday, right? On account of Raksha Bandhan?
No, ma'am.
No, ma'am.
Not a holiday? Today was a holiday?
We will be celebrating school, ma'am.
Yes,
No,
ma'am.
no, no. We'll have tuition on Thursday. I'm not asking for that. We have class on Thursday. I'm just planning to give you some homework. So I'm trying to check if it's a holiday for you so that you'll have time to do the homework.
No, ma'am. We are having school on Raksha Bandhan also, ma'am.
Okay, okay. What about the others?
Ma'am, we too have schools, ma'am.
Fine. Then I cannot give you the homework. Fine. This one, okay, fine. Anyways, children, just give me 2 minutes. I'm winding up. Take a screenshot of this one. They've already finished this earlier. This is a part of, exercise 8.4 in NCERT, but we have already done all these 3 methods earlier. But I want you to complete. I want you to work this again in your notebook. Yeah, take a picture. You can see the question here, the identity here. This is the identity. We worked it earlier, children, believe me. Yeah, please complete this. Please complete this. This one also. I'll explain it. Work it out in your notebook. It's very simple. Done?
Yes, ma'am.
Yeah. I think this is the last one. Oh, we have one more. Huh? Okay, this one, 9th one. Yeah, 9, and this is the last one. Yeah, this one. Please complete all this in your notebook. I'll just explain them in the next class, and we'll take up a different, part of trigonometry in the next class.
Ma'am, can you
Ma'am,
show
please show
the
the ninth?
ninth subdivision?
Oh, yeah, sure. Is it fine now? This is the 10th one.
Got it now.
All right, children. All right, children. So that was it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
Thank you, children. Good night.